Happy Mother's Day, everybody in geometry. I hope you said something nice to your moms today. All right, here is this. I scanned everything that's in the book for review stuff, including the self-test, which is kind of in the middle of the chapter. I'll put the page numbers up here so you can see where I'm at when I change sort of to a new file or a new page. All right, so I started on the stuff on page 496, number 1. Here we go. A rectangular solid with length 10, width 8, height 4.5. I'm supposed to find lateral area. Supposed to find total area, and I'm supposed to find volume. Okay, doesn't hurt to draw it. You don't have to, but here we go. Okay, length is 10, width is 8, height is 4.5. And so you might be going, whoa, I thought this one was supposed to be width. Doesn't matter. It's 10 by 8 by 4.5. You're going to get the same thing. With rectangular solids, it's, you start talking about lateral area, total area. With rectangular solids, it's really tough because any one of these sides could be the base. I could call the 8 by 4.5 side the base, or I could call the 10 by 4.5 side the base, or I could call this, the way I think they want you to do it is to think of the 10 by 8 as the base side. But with a rectangle, any one of them could be the base. So this one gets kind of tricky. Volume, it doesn't matter which side you use the base, you always get the same volume. Total surface area, you always get the same total surface area. If you decide different ones could be the base. But lateral area would be weird. I'm thinking of it this way. Lateral area in a rectangular solid is perimeter times height, or really it's the area of these 4 wall faces, not the top and bottom. Perimeter would be 10 plus 8 plus 10 plus 8. That's 20, 36 times the height, which is 4.5. Which is something I don't know really fast. All right. Yeah, someone said they couldn't quite see all this. Can I make it any... I can scroll it up just a little bit. You can see everything. Well, maybe not. Make it smaller? No, I can't. That's a bummer. All right. 36 times 4.5 is 162. Okay. Total area then is lateral area plus 2 bases. I'm going to try to be better about writing these formulas down, because you should too on the test. If I want to know what you messed up on, I can find it better if you do this, as always. Plus 2 of the bases, and the bases are 10 by 8. So I'm adding 2 copies of 80 to that, and I get plus 2 times 10 times 8, 322. Okay, and the volume is simply base, well, it's area of the base, isn't it, times the height, which is, oh, area of base I just found out. And here was 80 times 4.5, 320, and 40 is 360. Right? Okay, great. Okay, same page, number 2. Regular square pyramid. Looks like this. Again, you don't have to draw it, but it kind of helps. Lateral area they want, and that is going to be half times perimeter times L. Total area, which is that lateral area plus only 1 base here, because we just have a 1 base of the solid, and the volume is 1/3 because it's a pyramid. Big B times H. Okay, perimeter of the base, well, they tell us base edge is 24, and slant height, well, that's nice. They actually gave me slant height, because you'd have to find that. That's 13, although I do need to find height for this one. Height is not obvious. It's in the middle there. Perimeter of the base is 24 times 4, whatever that is. And slant height they gave me, so there we go. Half times 24 is 12 times 4 times 13. Hello. Hello. There we go. That's 624. So here I'm going to have 624 plus the area of the base. This has got to be exciting to watch. 1200. Okay. And area of the base I just did was 24 squared. Now the tricky part is, what's the height? I don't have the height. All right, so you got everybody's favorite thing in here is the, let's say, VA being the midpoint of that side, and point, I don't know, X is the middle of the middle of the square. VXA is a right triangle. We do a lot of these. Okay, this is 13. This is like the apothem of the square. It's half the side on a square. That's not bad. In equilateral triangle bases, this is really kind of a nightmare, but this isn't too bad. Pythagorean theorem will tell me that's 5. So that isn't bad. Okay, so back to here. 24 squared times 5, and I'll divide that by 3. 960. Great. All right, cylinder number 3. Lateral area is supposed to be perimeter times height. Perimeter in a circle is like circumference, so that's 2 pi r times the height, which is 7. 20 times 7 is 140. I'm going to leave this like this. If you want to decimalize it, be my guest. All right. Total area is the lateral area. Whoops. I'll just change this to lateral area. No erasing needed. Plus 2 bases, because there are 2 bases here. So that's the 140 pi plus the area of 2 bases, which is a pi r squared. So that's 200 pi plus 140 pi is 340 pi. Okay, volume is the area of the base times the height. I just figured out the area of the base was 100 pi. And the height is 7. So we're talking about 700 pi. Okay, here they want a hexagonal prism with height 5 and base edge 6. Be careful that, when you're drawing these, when there's no picture. We're talking about prisms here. It's really easy to mix up prism and pyramid, and then you're finding a third here, and you have totally wrong formulas for lateral area and all that kind of stuff. Lateral area is really not bad here. I have, when they say right hexagonal prism, that's implying that it's a regular hexagon at the top and bottom. So the perimeter here is just 6 times 6. Height is 5. Got it. This is 180. No problem at all. The area of the bases is going to be kind of a nightmare. So let me give me some more room here. Lateral area is the 180. Fine. Plus, I got to add two of these hexagon bases. Okay, we did this a lot last chapter, but not so much recently. You could do apothem times perimeter, which isn't too bad. Half AP for the area of the hexagon. If this is 6, how long is that? Well, this is a 30, 60, 90 kind of triangle in here, and this is 6, and this is 3, so this has to be 3 square root 3. Okay, so this is, I'm going to need this area of the base here. I'll just mark this as big B because I'm going to need it here and here. All right, half times 3 square root 3 times perimeter, which is 18 times 3 is 54, right? Okay. 2 of these here. Look at this, I got a square root of 3 and a pi in the same, oh no pi. In the same thing. 180 is not going to combine terms with this thing. This is just going to be 108. What was I thinking? Pi was in here. Okay. And then volume is base times height. I know the area of the base. I just figured that out. And the height is 5. 54 times 5 is, I want to say 270. Square root 3. Okay, great. All right, half times the perimeter of the base. Well, perimeter of the base in a cone would be the circumference, 2 pi r times slant height. Okay, now I don't know slant height. But I do have a nice right triangle here with the 9 and the 12, and I'll just use Pythagorean theorem, and I'll find out that's 15. And gosh, I got this bunch of stuff to multiply together. Oh, just really 9 times 15. 9 times 15, I don't know in my head, but I don't. 135. Okay, so I'm going to take that. I'm going to add on a base, which is pi r squared here. So I'm just adding 81 pi to 135. 81, 13 plus 8 is 216. Great. All right, and then the area of the base, which I just figured out was 81 pi, times the height. Now here's where I actually use the 12. So notice I use the 15 here and the 12 here. Totally different. What's 27 times 12? 324. There you go. Whew, I hope you're having as much fun watching these as I'm having fun making them. Okay, we're done with that first set of instructions. Now the instructions are different per question. Total area of a cube is 2400. Well, good thing it's a cube because I don't have to mess with separating out lateral and base and stuff. I just know the area of that thing is 6 squares. So if the total area is 2400 and that's 6 squares, I know that each square has an area of 400. As an area of 400, then I know that x times x is 400, so I just need to take the square root of 400 to find out what x is, and that's 20. Okay, and once I have the edge on the cube, I can pretty much do anything I want after this. Find the volume. The volume is just 20 cubed, which is 400 times another 20, which would be 8,000. All right, this is starting to look more test-like. Solid metal cylinder with radius 2 and height 2. So, radius is 2, height is 2. When they say recast, they mean like melt down and made into another shape where you know the volume is going to be equal. And now it's a cone. It's kind of like the ice cream questions that fit in the cone when it melts. With radius 2. And the question is, what's the height? Well, you know what? I could spend a lot of time doing this and figure out this volume and make sure the volume is supposed to be equal and find out, solve this for h. I just know this. If it's supposed to have the same base, if I just made a cone, let's pretend I made a cone right in here. It was this big, which I'm not going to do, but I can change color to it. If I made a cone right like that, this cone would be 1/3. You know, the volume on a cone is 1/3 of the cylinder it's in. So if I just made the same size height cone, it would just be divided by 3. If I was supposed to keep all this metal and make it a new cone with the same base, it's going to have to be 3 times as tall. Because when I take this volume and divide by 3, it's supposed to equal that one. So I know it has to be 6. Again, you could go to the trouble of actually finding the volume. I could go ahead and do that if you really want to. My prediction is it's going to be 6. Let's go ahead and do that. This would waste a lot of time on a test, though. So I'll say right now it's going to be 6. But here's why. Here's sort of a proof. I'll do it here for you now, so you don't have to do it on the test. Volume here is actually area of the base times the height. Area of the base is pi r squared times height. This is 8 pi. And this is supposed to be 1/3 area of the base times the height. And I'm saying it. In the book they're saying that has to equal the same volume as the cylinder over here. Area of the base is still 4 pi. If that equals 8 pi, I can solve this now for h. Divide both sides by pi, divide both sides by 4. And then I have multiply both sides by 3. And I get, guess what, h equals 6. Took a lot longer than just going, oh yeah, it's 1/3 of the volume. So if I want to keep the same volume, I have to triple the height. So it would be 6. And here's another reason why, do that last problem that way, just by sort of logicking it out rather than actually finding volume. Here you can't actually find volume. It's a great problem. You have some bizarre triangle base, and there's a prism built on it. I have no idea what this triangle's area is. I just know this one has a height 2, and I have a congruent one over here, and it's a pyramid. So whatever that triangle is, it's a pyramid of height 5. The volume of this thing is area of the base times the height, which is 2 times the big area. This one is 1/3 area of the base times the height, and it's the same b as this one. This is, so it's really 5/3 times that base area. What's the ratio of these volumes? It says ratio of the volume. I don't know which one they want sort of on the top of this fraction, but I could just say, well, the ratio is, this is 2b, this is, not 2b, no, this is 2b, this is 5/3 b. The ratio is 2 compared to 5/3. 2 over 5/3 is like saying 2 times 3/5, which is like 6/5. So I kind of like that answer actually. That this volume is 6/5 as big as this one. If this were, remember, like if this were